Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about subtopic 3.5 in chapter 3 about resistor in series and parallel. Basically, a resistor limits the flow of the charge in a circuit where V is equal to IR. Most circuits have more than one resistor. If several resistors connected together and connected to a battery, the current supplied depends on the resistance in the circuit. The equivalent resistance of a combination of resistors depends on both their individual values and how they are connected. The simplest combination of resistors are series and parallel. In the series circuits, the output currents of the first resistor flow into the input of the second resistor. Therefore, the current is the same in each resistor. Resistors are said to be in series whenever the currents flow through the resistor sequentially. Since there is only one path for the charge to flow through, the current is the same through each resistor. The equivalence resistance of a set of resistors in a series connection is equal to algebraic sum of the individual resistance. For each resistor, a potential drop occurs that is equal to the loss of electric potential energy as a current travels through each resistor. To calculate effective resistance in the series circuits, sum of the resistor in the series is equal to the effective resistance. Value of effective resistance in the series circuits is always greater than any individual resistor. Next, in parallel circuit, resistors are in parallel when one and of all resistors are connected by continuous wire of negligible resistance, and the others and of all resistors are also connected to one another through a continuous wire of negligible resistance. Each resistor has the same potential drop across it, and the current through each resistor may be different depending on the resistor. The sum of the individual currents equal the currents flow into the parallel equation. To calculate effective resistance in the parallel circuit, we will use the formula 1 over R1 plus 1 over R2 plus 1 over R3 is equal to 1 over R effective resistance. The value of effective resistance is always less than the smallest resistance in group.
Assalamualaikum and very good morning. I would like to discuss with you about subtopic 3.5 resistor in series and parallel. So I'm gonna discuss about tutorial question, which question number 7 in tutorial book. So let's get started. 7A1. Three identical resistors are connected in series. If effective resistance is 60 ohm, what is the resistance of the resistors? So we know the formula of the resistance in series is R effective equal to R1 plus R2 plus R3 and etc. Rn. It's given that 60 ohm equal to three identical resistors, R1 plus R2 plus R3. So just divide 60 to 3 because same value, the value is 20 ohm. Okay, 7A2, what is the resistance? Alamak.
1, 2, 3.
7A2, what is the resistance of the resistor that must be connected in parallel with 50 ohm resistor to obtain the effective resistance of 5 ohm? Okay, so the question given is R effective equal to R1 plus R2, which is R effective is 5, R1 is 15, and we do know this value. So in parallel we need to inverse the value. So 5 turn to 1 over 5, 15 turn to 1 over 15, and unknown. So subtract the value. We will get the value is 2 over 15. Inverse the value, we will get the value is 15 over 2 ohm, or equal to 7.5 ohm. That's all. 7B1, we can see that the value for 2 ohm and this 2 ohm is in series, so we just need to add them. R1 plus R2 equal to R1 equal to 2 plus 2 equal to 4. And for 4 ohm and this 4 ohm is in parallel, so 1 over R effective equal to 1 R1 plus 1 R2, which is 1 over 4 plus 1 over 4 equal to 2. 1 over 2, and inverse it to 2 ohm. Okay, for 7B2, it's given the value 12 and 4 is in parallel, so 1 over R effective equal to 1 over 12 plus 1 equal 1 over 4 equal to 1 over 3. We need to inverse it to 3 ohm. So we can add 4, 3 and 3 in series. R effective 3 plus 3 plus 4 equal to 10, and it will turns out to be in parallel for these two value. 1 over R effective equal to 1 over 10 plus 1 over 10 equal to 1 over 2 over 10. So the value will turns out to be 5 ohm. Question 7B3. This question is a bit tricky, so watch out. For these two value, we must calculate it in parallel. 1 over R effective equal to 1 over 2 plus 1 over 2 equal to 1. If we inverse it, it still turn out to be 1. It is in series with this value 1, so will be 1 or 1 plus 1 equal to 2. This 2 is in parallel. 2 1 over 2 plus 1 over 2 equal to 1. Inverse it, turns out will be 1, because this A and B is not connected, so these two value is in series, so 1. So R effective equal to 1 plus 2 equal to 3 ohm. Okay, for the last question, 7B4, this simple, this value 1 and 8 is in parallel. R 1 over R effective equal to 1 over 6 plus 1 over 8 equal to 7 over 24. Inverse it will turns out to be 24 per 7 ohm. This three value is in series, so just add it as in series. R effective equal to 4 plus 24 plus 7 plus 8 equal to 15.43 ohm. Okay, thank you very much.